Equation of the line, because we did that in semester 1. But let's be clear about exactly what I mean here, equation of the line. So, if you have a line, I'm not talking about this equation. That's not what I'm talking about today. Because if it was, that would be stupid, because we already studied that in semester 1. Instead, what I'm talking about is this. Vector equation of the line. I want a way to represent all the vectors that point to somewhere on the line. So I want an equation to represent these, not this. Now can you see the difference? In semester 1 we did an equation for the red line, whereas now in semester 2 we want to do an equation to represent all the blue lines. Can you see the difference? They're two different things.
Well, there are too many blue lines.
Yeah, like there's so many. So we need a way to represent all of them. Let me show you how. Okay? So, firstly, how many points do you need to make a line? Two. So let's just say we'll call this one here A, and we'll call this one here B, and we'll say we're given A and B already. So here it is in green, here is A, and here is B. And let me just extend this a little bit. Right, now we want a way to represent any of these points. So let's just call one of these vectors OR. Although OR, you understand, can move. Yeah. So, what way could I rewrite OR? Well, I could say OR is OR, but that's not really helpful. Any other ideas?
OB plus ER.
Yeah, OB plus BR, or also OA plus AR. Or in other words, A plus AR. But I don't like this because I'm using OR to define OR. So is there something else I can do here? Very good, Monica. And what way can I represent that in an equation?
Lambda.
Yeah, some constant, lambda or mu or t or whatever. So I'll call the constant t. T AB. So what we've just done now is we've made an equation. This here can be used to represent any vector that points to it. And the different values of t represent different vectors. So for example, this one here, you get that when t is 0. Because you're just left with A. And this one here, you get that when t is 1. Because you'll have A plus B minus A. So what about the point that's in the middle? Well, no surprise, that would be t is a half. And what about if t is more than 1? Your vector's out here. And if t is less than 0, it's out here. So this is the formula, Jerry, to represent all the vectors. Okay, Jerry? Continue. So this works if you have 2 points. But what about if you have something like this? Oh, can I scroll down? Way to chew. Yeah. Okay. So what about if you have this? You have a vector. Let's just call this vector, I don't know, C. And you have a point here. Let's just call it A. And let me put O right here. And I want all the vectors that point to this line. the line which is passing through A, I shouldn't really say that's a vector. The line which is passing through A and is parallel to the vector C. So in other words, I want all of these vectors. Right, let's try this again. Let's see if we can make a formula. Yeah, this red line is parallel to C. So OR, that would equal OR. What could I say OR equals? OA plus AR. Yeah? OA plus AR. But I don't want OR. So what can I replace the AR with? No. T what?
Will you see?
Yes. TC. Yeah. Because these are parallel. So all these vectors here are multiples of C. So this is the formula if you have this situation where you have an A which is on the line and a C that's parallel to it.
Y is parallel.
OR?
Yeah.
No, OR is not parallel to C. This, for example, here's OR. That's not parallel to C. I'm saying AR is parallel to C. Yeah.
Isn't that minus TC?
It doesn't matter because it's just the way I drew it. You're allowed, T is allowed to be positive or negative, so it doesn't matter.
A is parallel to C.
A is not parallel to C. Only AR is parallel to C.
But AR, that's a lie.
AR is parallel to C. Jerry, yeah, this is A, and this is vector A. Oh, this way?
The red line is parallel to C.
Yeah, this, yeah. Continue? Yeah? No? Can I have a look at the questions I gave you? How hard did I go today? Let's see. Easy. Easy. Oh, so easy. All for babies. No, just joking. Something a little bit harder now. Can I scroll down? Yeah? Jerry?
Yeah.
Okay. So now, let's imagine we have this. This is line L, and this is line K. And let's say here is O. So, we have all the vectors that point to K, and then we have all the vectors that point to L. And the equation will say for this one here, this is the L one, we'll say this is OR equals, we'll just say A plus T AB. Now, it doesn't really matter, I just want to write a formula down. Now, because AB is a vector, I'll just call it something like, I don't know, what do I want to call it? A plus T C. And then for this one, I'll say its equation is OR equals B plus TD, for example. Yeah. Now my question is, what is the angle between these two lines? I want a formula. I want a formula for the angle up here.
What's the angle?
That's what I want. I want a formula.
Which angle? Which angle?
Oh, well, it doesn't really matter. We can just say this angle, but if you, the formula gives you either the acute or the obtuse, so you can just do 180 minus. So it doesn't really matter. Let's just say, for the picture, this angle. Fine, previous angle, it doesn't matter. I want the intersection angle. Well, you know the formula, don't you? Or dot over magnitude. But the problem is, what factors do we use as the dot, and what do we use as the magnitude? What factors do we use? Which one? Like we have so many vectors. We have or, B, D, A, C, or. Oh, you're going to put in another vector. Is it?
A and B.
What?
No.
A.
Not A,
But
B.
we don't have the value for them.
Oh yeah, I'm saying pretend we know A, C, B, and D.
Oh.
I'm just writing down these letters as placeholders.
Red, orange, blue.
You can just make this times D.
Which? What Chrissy said, the red or and the blue or.
Yeah.
Yeah, but that will give you the angle between these vectors. Because remember, or,
Oh,
yeah. So that's not what we want.
Mhm.
But what vectors are L and K? But I don't have any OL and OK.
Just use the vector parallel with K, and the vector parallel with
Which vectors are those?
this.
Yeah, but which letters are they? Which letters?
What is OB? What is OA? Just make
OB and
Yeah,
OA?
make OB parallel with OA parallel with K.
Why not?
No.
I mean that works.
Oh,
Because
oh,
this angle
they
is
are-
equal to this angle.
They are vertical. They are 90 degrees.
What are you saying? Like OA?
Yeah, OA is parallel to K, OL parallel.
No, but you can't do that because A is some point on the line. Do you remember in the formula, A is a point on the line
Yeah.
and C is along the line?
Yeah, we can.
We can neither A
Oh,
or A.
You
We
can't.
can now.
Oh,
We
we
can.
It has to.
Just we have to make the two angles equal. They are both equal 90 degrees, and then we can.
But we
Okay.
can make it like more than the.
I thought that.
Like we are not changing point A, but R. We use OR to parallel to K, then O another R.
So you say bring this fella down until he's parallel to this line,
Yeah.
and then bring the other one until it's parallel to the other line,
Yeah, and then we get them.
and then get the angle.
And then it's parallel.
And yeah, that's hard, but possible. Let me tell you. So remember what this vector is. This is some point A on the line, and then what's C? What was C in the formula?
I don't
It
know.
was AB.
AL.
No, if you go back to the first one, this is like the C, okay?
Yeah.
What is C on this diagram?
A.
AB,
Yeah.
which is a vector on the line. So, what I'm saying is, this C here is like some vector on the line.
Yeah.
Well, that vector is the same as this vector, isn't it?
Mm-hmm.
Which is the same as this vector.
Yeah.
And you don't care if it's bigger or smaller. And likewise, this
Oh.
vector... Oh, now hang on. This is...
What's
Ah, yeah, now it's all
the
making
D?
sense. Yeah.
We are so dumb.
No. That's it. So for the lines, you should use the vectors which are the coefficients of the variable.
Wow.
Amazing indeed. Can you write this down? This amazing thing. Now we'll do one more sort of theory point, and then we'll have a look at some examples. Is this new for everybody? That's good, because this is the most important thing on the exam. So everybody is on the same difficulty. Now the thing is, once you get this and do a couple, then you realise, oh, this is a good exam question, because it's just put the numbers in the formula and you're finished. Once you know what formula and how to do it, you know. Hey, well, see, that's the problem. Continue. Yeah, but even with the formula book, you wouldn't know which vectors to use. Yeah. Right. Next point. Imagine again we have a line. We'll call this line again A plus TB. And imagine we'll have a point here, I call it C. Sorry, that's OR. I want to know what is the shortest distance between the line and C. It's a perpendicular, but how can I find this? Let's see. So let me just call this point here O. So again, all of these, what are these vectors here? These are all OR. Now the one we really care about is this one. This OR that points to the same place where the perpendicular is. So this is the one we really care about, isn't it? Mm-hmm. Okay. So we'll call that point there OR. And on this line, what is the vector B? This is the vector B here. B is on the line. Yeah? Right, now, let's call this distance here D. So we want to get what the D is. Well, on my picture, the D would be the magnitude of what? C or.
Wow. Yeah.
Yeah? Now, rather than get the D, let's try and get a formula for the D squared. That's a little bit easier. Does anybody remember what this is equal to? C or. It's equal to C or dot C or.
Yeah.
Yeah? Is that okay? Yeah. Which we could write as or minus C. Yeah. Dot or minus C. And that can be expanded as or dot or minus or dot C minus C dot or plus C dot C. Yeah? Is that okay?
No.
Now that will equal or squared. Where am I going with this? Minus 2 C dot or. Hang on, now I've screwed this up.
C square.
Square, yeah. Yeah, no, forget that.
Oh my god.
Oh, come on, give me a break, I'm tired.
Not kidding. I write nothing. Andrew.
That's reassuring that you had so much faith in me. I'll give you a minute, Andrew.
What do you want?
To be honest, I'm not sure right now. I think I need some more coffee.
Okay. I would like.
Just give me a moment. I need to contact my inner Stephen. Right. Right. So this point here is A. Okay, so I was confused. I forgot what I was doing. This is what I'm doing.
Okay.
Next, yeah. The key here is you need to, part one, you need to find T. You need to find the T that makes the vector point to this point. If you find T, then you have found OR, because you can just put the T into this, right? If you found OR, then you have found COR, because COR is just OR minus C. Yes? If you found COR, then you have found D. Because what is D? The magnitude of CR. Can you understand this? Yeah. So my mistake, what I was doing is I was trying to start from here. This is actually too difficult. It's much easier if you can try and find the T, because as soon as you find the T, then you found the R. And then once you know the R, you know the CR. And then once you know the CR, you know the D. So now the real question is how to find the T. Well, we know this point here, this is A. How can I get A? This is when you just make T equal to 0. If I put T equals 0, I have the A. Yeah? So what I'll do is, I'll say AR is perpendicular to RC. But if they're perpendicular, what does that mean? What's the relationship? No, they're dot. AR, yeah, equals 0. Now, you can change that into R minus A dot R minus C. Or C minus R. Actually, funny enough, it doesn't actually matter, Jerry, because since it's equal to 0, I can just change the sign. So I'll like to write the R first, if that's okay. Now, that's it. You might think, what? What does he mean that's it? Well, think about this. This guy here, this will have T in it, yes? And this one here will have T or no T? This will have a T, and this will have no T. And this one here, T, and this one here, no T. When I subtract them together, this will have a T, and this one here will have a T. Like, for example, it could be something like 2 plus T, 1 minus T, 3 minus 4T. You know, something like that. Okay, so these both have T's. But when I dot them, what type of equation will I have? You see, this is linear and this is linear. And when I dot them, what will I get? Yeah, so what type is that? So in other words, this formula will make a quadratic in T equal to 0. If I solve this quadratic in T, then I've done the first step, which is finding the T. Now that I have the T, I have the R. And now I have the R, I have the CR. And now that I have the CR, I have the D. So the key was seeing that the dot has to be 0 if they're perpendicular here. And you can change that into this equation, which gives you the T. And then once you have the T, you're finished then. Yeah. Now, let's do some examples. Yeah. Okay. If you want to put this into words, you can write it like this. R minus a point on L dot R minus the point. In this case, the point is C. That should equal 0. That's like the formula to get the T. The point on L being the A here. Don't worry, I'll explain this again with another example. Continue? Not yet. Your page is so nice and shiny with the Tipp-Ex on it. It's wonderful. Perhaps good investment.
So what do we know?
We'll know A, B, and C. Sounds like you're about to have a breakdown. No? Example time? Good, thank you.
The point what?
The point on L.
And
The point. The point C. Okay, example time. Right. I'll do one part A. I have the vector 6, 14 and minus 12, and the vector, woohoo, spooky, minus 6 and 6. And I want the midpoint. What's wrong, Sean? Page 7. Sean!
yeah.
How can I get the midpoint, the middle point of these two? You're not Sean. You wish you were Sean. You're not Sean. Yeah.
Plus and
Yes.
mid
No, go on, yes, plus and then?
and over 2.
Yeah. So, 6 minus 6,
0.
14 minus 6,
8.
divide 2,
4.
minus 12 plus 6,
Minus 6.
divide 2,
Minus 3.
that's the answer.
It's 3, 0, 3, minus 3.
What? This one?
Are you kidding me?
It's 3, isn't it?
4.
Your math is teach by PE teachers?
Oh, Sean, be nice. Be nice. He's not nice. He's not nice.
What did you say?
I'm not teach by
Sports teacher. See, he's a funny guy. Funny guy. All right, B. Sorry, not B. I mean 2. 2A. Okay. In each case, the first vector points to a point on the line, and the second vector points along the line. Find the equation. So what I mean is, here you have a point on the line. So the first one is minus 9, minus 2, minus 8. Okay? And then the second one, I tell you, is on the line. So this one here is 1, minus 1, 3. Now, which problem is that? My first or my second example? Second. Yeah. So if I want the vectors that point to this line, so if I want all these vectors here, what's the equation? I would say OR equals the first, the point, plus T 1 minus 1, 3. Which I can write like this. Yes? Question?
Can you repeat? I don't understand the drawing.
These 3 numbers represent this point.
Isn't it line?
What is?
3 numbers.
These are just the coordinates. It's pointing to this point. Those 3 numbers represent this vector that points here, which we can call A. Those 3 numbers represent this vector, which we can call points. We can call that vector B. This is the answer. So you realize, this isn't so difficult because I just add them together with the T. But you would get this in the exam. Hold on, one at a time. Jerry first. I heard him first. Go on, Jerry. Oh, why don't I do minus? Because I told you in the question that the B is already pointing on the line. Just to be clear, Jerry, you can have this,
All points.
or you can have this. So in the question, I gave it to you like this. Now, if I gave it like this, yes, we would have to do b minus a, which I think is the next example. Can I scroll down? Yes? Going down? Okay. 3a. So again, I have a line, and I have this point here, which is 6, 7 minus 6, and then I have this one here, 2, 2, 2, and I want all these vectors that point everywhere on this line. Okay, so this will be or equals 6, 7 minus 6 plus t times ab times this vector. Yeah, 2 minus 6, minus 4, 2 minus 7, 2 minus minus 6,
8.
and that's the answer.
Equal 1.
No, that's the answer. This is the or.
And those ones, T.
Not for these ones. Later we will now. Next. Continue. Okay. The next example I actually didn't talk about, but I think you should know an idea how to do it for A. I give you the line, what's that, 4 minus 10t? Yeah, go on, Monica, please.
4 plus 1t
Yeah.
minus 6 plus 2t.
That's one line. And I also give you another line which I call using S.
2 plus 8s
Found 8
minus 7 minus 12s minus 8 minus 5s.
And I say these two lines meet. Where do they meet? Yeah, where do they cross? So how can I find this point where this line and this line meet?
all equal.
Just make them equal. Because if they meet, then they should have the same value at that location. So it means this should be equal. Oh, well, this is easy now because you just made 3 equations. Wait a second. You made 3 equations, but there's only 2 unknowns. So what you usually do is you use the first 2 in the exam. They would expect you to use the first 2 to find, and then use the third one to check. So you would say 4 minus 10t equals 2 plus 8s. So that means 8s plus 10t equals 2. And likewise for the second equation you can say 12s plus t, I take the 12 over and take the minus 11, isn't it? Okay, and I want to solve these. Yeah? What'll I do? Will I multiply by, or if I want to multiply by 10? I could divide this by 2, but I'll just multiply by 10. So that's 120, 10 and 110. If I subtract, that's 112s equals minus 112. So nice. S equals minus. No, I did the second minus the first. Yeah. So S is minus 1. If I put that in, that's minus 1. So that's a plus. So T is 1. So let's check. Minus 6 plus 3 is minus 3. And minus 8 plus 5, minus 3. Okay, so it works. So what's our answer? They meet at, well, I know that's minus 3. If t is 1, that's minus 6 and 5. Or if s is minus 1, that's minus 6, yeah, and 5. So this is where they meet. This, again, this is a common exam question. Quite common. Yeah, but the actual questions are not hard, I don't think. Oh well, hang on. Are they hard? The questions though? Continue? Yeah? Okay, now. My pen. 5A. Find the angle between, actually Monica, it's easier if you read it out to me. What's the first factor?
8 minus 3t.
Yeah.
4 plus 2t.
Yeah.
Minus 8 plus 1t.
Okay, and the other one?
5 minus 2s. 6 minus 10s. And minus 7 plus 2s.
Now, do you remember, if I want the angle between these two lines, what vectors should I use? I should use... Yeah, so what should I use? Give me the numbers. Tumbleweed. Do you remember I did this example? What did I say to use?
Question minus.
There we go. Minus 3, 2, 1. And here? I said to use the coefficients, the C and the D. Well, this is easy now. Cos theta equals dot. Minus 6, minus 26, plus 2, minus 24. Over magnitude, 9, 10, 14, for 108. So, easy peasy. You got the theta. The theta 128 degrees. That's the obtuse angle. If you minus 180, you'd get the acute angle. What? You just told me it's 128.
I don't want to make the calculation here in the YouTube.
Well, maybe I did something wrong here. Minus 3 times 2 is minus 6. Minus 6 minus 20 is minus 26. Plus 2 is minus 24. On the top, right? And then this is square root of 9 plus 1 plus 4. 14. 9 plus 1 plus 4? 4 plus 100 plus 4. 108. And I did write these down. Minus 3, 2, 1. 2 minus 10, 2. And the answer at the back is 128. 108.
What minus 2?
That's a minus 2?
Yeah.
Oh, Monica.
Monica.
No, it's too late. Too late! 6 minus 20 is minus 14 plus 2. Is this, what's on the top now? Minus 12? 6 minus 20 minus 4. Is it minus 12 on the top? What's the angle now, please, Monica? Thank you. I'll ask my good friend Chu to help. Chu, what's the theta here, please? No, don't. Did you type it in? No, don't trust me. Don't trust me. Don't trust me. I'll trust Chu. He's making sure it's right. Yeah. Oh, that's radians. Let's get degrees. Shh. 108. 108. What's the answer at the back? What's the answer to that?
Einige something.
Is it 108?
Something good.
Great. Alright, number 6 now. So, Andrew, you give me number 6 now.
Okay.
I'm picking on Monica all the time.
Minus 4 minus 3 and 6 minus 3 plus 9.
What?
No, it's like...
Sorry, no, you've blown it now. You've blown it. Monica,
4 minus 2.
4 minus T.
Minus 4.
No, alright.
Oh, come on. Minus 4 minus T.
Minus 4 minus T,
6 minus T.
6 minus T,
9 minus 17.
17 T. Right, now this is the line here. And then I probably give you a point.
5, 4, 7.
5, 4, and 7. Okay? Now, if you look at this line, what you have is this. This is the point minus 4, 6, 9. Here. I'll call this O. Yes? And then what is this vector here? This one here is minus 1, minus 1, minus 17. And then this one here, that's perpendicular, whatever. This one here is 5, 4, and 7. And if you remember, what is key is that this is perpendicular, and I'll call this point here OR, and I'll call this point here A, and I'll call this point here, I'll just call it P. So what is the relationship between A, OR, and P? And this is OR, and this is P. Yeah, A, OR, dot, OR, P should equal 0. So that means OR minus A times P minus OR should equal 0. Because it's equal to 0, I can multiply it by minus 1. So I get OR minus A, OR minus P equals 0. So let's calculate that, OR minus A and OR minus P. So here's OR minus A, dot OR minus P should equal 0. So there's OR. Oh, sorry, what the heck is A? Oh, there's A there, sorry. OR minus A. I'll just write A here so I can see it clearly. Minus 4, 6, and 9. Right, OR minus A. There's OR, there's A. Let's minus them. Minus 4 minus T, minus 4. So that will be just minus T. Because the minus 4 and the minus 4, they cancel. Yeah?
Do you have R?
This is OR. I'm doing OR minus A. And then the next one will be 6 minus T minus 6. Now you see, this is quite nice. And this, I don't think this is happening by accident. I think this should happen. Because you see in the last one, what are you left with? Minus 17 T. Yeah? Now if you look at what you have here, that's minus 1, minus 1, minus 17T. Where are those numbers? That's these here, isn't it? But you realise, oh, of course it is, because AOR is the same as what? It's the same as this, the B. So of course it should be the same, except multiplied by T. So we could have also said that the B is here, but no big deal. Now this one here is OR minus P. Where's OR? Here it is here, minus P. Okay, this one won't be as nice. So, OR minus P. So minus 4 minus T minus 5, that's minus 9 minus T. And then the next one is 2 minus T and 2 minus 17T. Now because this is equal to 0, I'll multiply by minus 1 and go plus, plus, plus. Yeah? Let's expand. Minus 9T minus T squared plus 2T minus T squared plus plus 34 t. Oh, what's 17 squared? Huh? 289, thank you. 289 t squared equals 0. Can I find the t? Definitely. So let's solve this now. That is lazy. Let's get the calculator. Do I have it open? Oh. Slide me that calculator, Andrew. I'll get it here. Right, what's A? A is minus 291, yeah? What's B? 34 and 2, 36. And minus 9, 27. And the C is just... Is there a C?
No.
0. Ah, okay, that's fine. So you get two answers. Either T is 9 over 27 or T is 0.
0.
What? What did we get? I'll type it in again. Minus 291 plus 27. Oh yeah, sorry. What did I say? Alright, 97. There you go, 100. Thank you. Right, now, we have two answers, but when we look at the picture, we should have only one answer. So one of these answers we should reject. Yeah, well, we kind of feel like the 0 is wrong, because when t is 0, I get A, and it's not going to be at A, it's going to be over here. So we reject this answer, which is normal. Now that we have this answer, I should put it back in, here. Okay, so let me write that down on the calculator. Minus 4, now, minus 4 minus 9 over 27? Oh my goodness, 9 over 97. Uh-oh. I was trying to do something fancy, I saw. I don't know if I did that right. I was trying, there's a way to store answers into, you see this button here, A, B, C, D, E, and F. You can store the numbers into those letters. But I forget how to do it. I think this button here is store, S-T-O. So if I type shift, store. Ah, yeah. So I've just put that number into A. Did you all see that? Watch again. 6 minus 9 over 97. Shift, store, and then just press B. Now I've put it into B.
How do I cancel this number?
So
9 minus 17 times 9 over 97. Shift, store, C. So now if I type alpha A, I get my first one. Alpha B, got my second one. Alpha C, got my third one. Pretty handy, huh? So, now that I have my three numbers, what do I do with my three numbers? Well, I have OR, so now I need to get OR P. And how do I get OR P? P minus OR. So first I should do 5 minus my first number, 4 minus my second number, and 7 minus my third number. Well, the good news is I still have 3 more letters. So, my first one is A. Hang on. A minus, what am I doing here?
5 minus A.
Or it doesn't matter if you do it backwards. A minus 5. And let me put that answer in letter D. Next one, b minus 4, and then we put that answer in E. And then lastly, c minus 7, and I'll put that answer into F. So now where are my answers here? They're in D, E and F. So first one, D is that, and E and F. But I don't want D, E and F. What do I want? So I can do square root square root D squared plus E squared plus F. Thank you. Oh no. There we go. F squared. Now the reason I'm doing this is because then I don't have to, like, I can obviously do it quicker with my fingers, but I don't have to write down all my work. So I get an answer here of 9.3 as the shortest distance. Now this is the most advanced question on the exam. I don't see this so often. I have seen them ask you for the angle many times, but shortest distance, maybe 20%. Alright. Try these for a couple of minutes and then we'll have a tutorial. What questions are we looking at? You said there was a trig one, Chrissy? Chrissy?
Vector and two vectors.
You don't want a tutorial? I thought you said you had a trig question.
Yeah, but I mean, I spoke yesterday, I think, or
Okay, we just practice more vectors?
Yeah, well, as a vector, I'm not good at drawing.
But don't worry, they don't ask you to draw in the exam.
But I just want to know, like, yeah.
But it's hard to draw 3 dimensions and 2 dimensions.
That's what
No.
I spoke
So they don't ask you to do this in the exam.
I don't need it.
No. If you really wanted to draw a vector, you would use a graphing program to get it in 3D, so you can actually look at it. Like my program I have has a 3D graph feature, so you could draw shapes in 3 dimensions. This way it's clearer because you can kind of rotate the image.
I'm okay.
Okay. Lee, can you put the light on, please? Yeah. Stop beating up the students that are smaller than you, please, and do your maths. I saw you punch him.
Oh my god.
Please do not abuse my students, thank you.
Who am I?
Please don't. Please.
You can just finish the 3
Is there only one lesson left in vectors?
No, sure.
But I'm saying since you have that like 3 by 3, you should just finish it.
Finish what?
The question, yeah.
No, she doesn't have it anymore.
Oh.
So,
I think I have a question.
you have a question? On which,
Like plus minus sort of.
in which lesson?
Base.
My signs are wrong?
Yeah.
Are you sure my signs are wrong?
Yes.
Are you 100% sure?
Yeah.
What lesson is it?
Base. Guitar.
Yeah. Yeah, you saw my YouTube comment. I wanted to know how I can dislike something more than once. Now, just so you know, though, sometimes the sign is not important. Like, for example, Lee was asking me earlier, shouldn't it be a minus because the vector is the other way around? But you actually, because the t can be plus or minus, you don't care if there's a minus in the formula because you can swap it around. So sometimes with the vectors, the minus is not important because it's just flipped around. So what question had the sign error?
OA plus OB plus OC plus OD equals to
Yeah.
lower vector. And I got 2 plus root 3 over 2. But it was minus 2 plus root 3 over 2.
Oh, so that's just a typo on my part then.
No, the whole thing. Yeah.
What? What?
What do you mean?
Show me the question. Which question should I look at? What number? In number 4?
Yeah. So it's from 3. And it's finding D. And then
Oh yeah, so that's my typing mistake.
the whole part of here.
Yeah.
Or here.
Well, if I look at the answer at the back for A, what did I get? So you're saying I have the wrong answer. So I typed it wrong. Your answer is different to mine. Is that it? Well, what answer did you get?
Here.
Where? Oh, keep away from my coffee. What's that? I can't make that out. What the heck is that? That's a plus and a plus.
Yeah.
Oh. What? I can't believe this. 3 root 3
Yeah.
over 2. And what's that? An I.
Yeah.
That's for the A, is it? The A is 3 cos 30.
Yeah.
Put the number and don't tell me.
Oh yeah, that's it there. So that's right.
Type the number
Okay. So which one is wrong?
plus 40.
4, okay.
Then
Divided by 2.
minus the number is in plus.
Oh, I saw. So, if I like
Yeah, that's the D, and change the sign.
that is one.
Yeah, the D. Yeah, D is minus A plus B plus C. So A plus B plus C is answer 3A, B and C. So if you add these together, that plus that plus that will minus. So 3 root 3 over 2 minus 6 root 3 over 2. That's minus 3 root 3 plus 1. But then I have minus them. Root 3 minus 1. Yeah, there's a sign mistake here. Yeah.
Hello.